So 4 times 2, that will give me 8, right? 4 is a perfect square, so it's possible. Now 300 by 2, that is 200. 2 over 3. Now what is root 162? Check the factors for me. Root 162, what are we going to use? 81 times 2. Good. Now, I hope you agree. Root 4 will give you 2. I can't obtain the root of 2, so I leave it as it is. There is 10 root 2. There's nothing we can do about it. 9 root 2. Agree? Good. Now, remember, say, outsider, you remain outside. 30 root 2. 3 to 6 root 2. Now, are these sets compatible? Yes, they are. So 6 plus 30 plus 6, all root 2. Now, this will give me 42 root 2. Good. That's all. Root 3k, root 18, root 98, root 50. Now let's try this question. So it's a sample further mathematics question, 2007 private question 10. Given that root 3k plus root 18 minus root 98 equals root 50. As usual. Now, there is nothing you can do about root 3k. Now this can be 9 times 2, the factors to be used. Now check root 98 for me, factors to be used for 98. 14 times 2. 49 times 2, thank you. And it is 25 times what? 2. Good. So I have root 3k plus 3 root 2 minus 7 root 2, 5 root 2. Now, I can have root 3k plus 3 minus 7 all root 2 equals 5 root 2. You rearrange again, so don't worry. Root 3k minus 4 root 2 equals 5 root 2. Root 3k equals 5 root 2 plus 4 root 2. Got it? I took this to the other side. Good. Now over here, root 3k equals 5 plus 4 all root 2. Root 3k equals 9 root 2. Wow. I've been asked to find k. Look at where k is hiding. It is in a shell. That is a square root, right? What do? And I have to square both sides. What is good for the goose is good for the gander. So you have to square both sides, right? So you square the left hand side, as you can see. You square this side as well. So this is 3k squared. I think just 3k, right? 3k, good. When you square a square root, the square root disappears, right? Last time I proved, I'm sorry, right? Good. Now that is 9 squared is 81. The square root here will disappear. You get 2. Now 81 times 2. 162. Now divide. What do you get for k? 54. That's the value for k. Now let's look at multiplication of sets. How do we multiply sets? It is the same binomial multiplication that we saw in algebra. Let's see if you have this. Remember a by the whole of that. That's the precedence that we normally follow. There's it. So this against the whole of that, this against that is it. So you're going to get a, c, a, b, yes, that is it. Now, let's look at how we are going to multiply this. Will you follow the same pattern? The answer is yes. But most students have problems here just because of the roots. But we also went through the properties. So we will apply them well. Now let's go. 3. So 3 against this. Minus 2 root 2 outside against that. Same as what we see in algebra. Now 3 by 3 is 9. Now 3 times 2 root 3. That is why the confusion sets in. Now if you think I'm not so clear, try a sample here and watch. Try a sample, right? Okay, this is outside. That is 6 root 2. This is what I'm going to get. You cannot use eye inspection. Use hand inspection. Good. Now, minus 2 root 2 by 3. You see, outside. That will give me minus 6 root 2. This can never enter in. Minus 2 root 2 by 2 root 2. If your eye inspection is not working, try this. So minus 2 root 2 times 2 root 2. So outside, that is minus 4. Inside, that is root 2, all squared. Did you see that? Good. If the eye inspection is not working, try hand inspection. Don't forget. So that is off. Good. So that is what creates problem for most students. Yes. 6 root 2 minus 6 root 2, this will give me 0. Now that is 9 minus 4 times 2. How did I get this? When you square a square root, the square root disappears, even from calculator or from properties of sets. So that is 9 minus 8. Answer is 1. It says, given the set root A plus root B, its conjugate set is this. So the opposite of this is this. So that's a conjugate set. Now the product of two conjugate sets will give you a rational number. So that is a set. That is its conjugate. When I put them together by multiplication, I'll get a rational number. Let's check. Now, how do we multiply sets? It follows the same principle like algebra multiplication. Now 4 is 16. Now 4 by root 5. You see, I told you, once you are outside and you're multiplying, you can never enter inside. But if this one happens to be root 4, then it can be root 4 by 5 inside, right? So 4 by minus root 5 is 4 root 5. Now root 5 times 4. 4 root what? 5. Root 5 times root 5 minus root 5 all squared. So minus root 5 all squared. Okay. Now minus 4 root 5 plus 4 root 5. This will give you 0, okay? So that is 16. When you square a square root, the square root disappears. Yes, no wonder. When you put two conjugate sets together, you get what? A rational number, not a set. Good. Now let's look at the other example. Go to rationalizing the denominator. What does it mean to rationalize a denominator? So the process by which you multiply the denominator by the numerator, and also for the denominator again, is what we call rationalization. Now, when or why do we rationalize? Let's see some examples here. Example: you cannot have an answer like this in mathematics. You see, it can be a fraction, but the denominator should not be a square root. When you say this, then we need to rationalize. We can have an answer like this. The denominator is not a root. That is okay. So anytime you are working and you see that no, the fraction is in this form, with the denominator having a root, you have to what? Rationalize. So let's look at this. 1 over root 2 can be rationalized by multiplying both the numerator and the denominator by the denominator. So I want to rationalize this. And why? This cannot be an answer. It's incomplete. Good. So this will give me 1 over root 2. I have to multiply this denominator by the numerator. By the denominator again. Good. What do I get here? I get root 2. Root 2 by root 2 is root 2. Double up. And you are going to get root 2 over 2. So when you square a square root, you can check on your calculator, the square root disappears, right? And there is a reason behind it. This is root. When you clear the roots, you are going to get this half. And take note, you are squaring this again. That's the 2 you are getting, right? Good. So when you square a square root, the square root disappears. Good. So this is when you rationalize. So when you are working and you come across your expression like this, your answer like this, right? It's not an answer, you have to rationalize. So the denominator becomes a free number, not a rooted number. Okay. Now let's make one question and see how we rationalize this, right? But before we do, let's check something here too. Note, root A plus root B can be rationalized by multiplying the SURD with its conjugate. So there is the conjugate of the SURD you see there. So when you want to rationalize this, that is root A plus root B. Multiply it by its conjugate, its opposite. Good. So in EMAS or further mathematics,